Part 2 of Chapter 3 is how to calculate things for fluid administration, IV fluid administration. So we're going to do a little bit more math. The rate at which to run intravenous fluids in drops per minute can be determined by dividing the volume of the fluids to be given by the time in minutes during the administration. So we're going to give how much volume? Mils per minute, right? But then we have to figure out if we don't have an IV infusion device, something that calculates it for us and pulls exactly the right amount of volume out for us. We then need to figure out how many drops that is per minute, or per second, actually, because it takes 60 seconds for a minute, right? So we don't want to sit there for a whole 60 seconds and count all the drops. In order to do that, we need to understand how many drops are in each milliliter based on what administration set that we use. Administration sets basically come in 2 or 3 sizes. There's basically a big one and a small one. The micro drip set, they're tiny little drops, and it takes 60 of them to fill up a whole milliliter. So 60 drops, or GTT is the other abbreviation for that. 60 GTT per mil. The other one is either 10 or 15. You just have to look to see which it is, and that's called a macro drip. And that delivers 10 or 15 GTT per mil. So they're bigger drops. So we're going to use the micro drip set for smaller animals. We want to be more precise and we want to give them less fluids. We're going to use the bigger administration set for larger animals. So if we think about it, this is our volume of infusion, so say 500 mils, 500 mils. Over the time of infusion in minutes, we're going to give it over 60 minutes. Okay. So 500 mils over 60 minutes is going to be, and then I have to get used to doing this, is going to be 8.33, 8 1/3 milliliters per minute. Okay, so we might be able to set our machine to do that. But say we don't have a machine. Now we need to figure out how to run those fluids without a machine. And this happens. You may run out of machines in your clinic, or your clinic may not have an infusion machine. So we need to figure that out. So let's say we have a dog that we're doing this with a 60 GTT, or we'll just put drops per mil set. Okay, so now look at this. We can cross those off because they're opposite. And this is going to give us, if we do 8.33 times 60, we're going to get, it's really hard, 500 drops per minute. So if you want to stand there for a minute and count to 500, that's totally up to you. I doubt that the people around you are going to appreciate that. What I'd like you to do is change that into seconds. So what are we going to do? We're going to multiply instead of equal. We're going to multiply and change it to seconds. We're going to put minutes up here because I want to be able to cross that off. And we're going to put seconds down here. So how many seconds are in a minute? 60. Okay? So if there are 60 seconds in a minute, now we're dividing 500 by 60 again. I already know the answer to this. We're going to do 8. You can do 8 1/3, but let's be serious. We can't count 1/3 of a drop. 8 drops now per second. That's pretty fast. Okay, so probably what we would actually want to do is do 8.33 times 15, a bigger drop set. That is going to give us 125 drops per minute. 125 over the minute, okay? Or if we want drops per second, 125 divided by 60 is going to give us 2 drops per second. I can count that, okay? So that's how we calculate drops per second. And actually, I would really like you to do that because standing there for 60 seconds is going to take you forever. The drip rate in drops per minute can, like I said, divided by 60 drops per second. So it's easier to work with. So I just did an example, but here is another one because the more we do it, the easier it is. So what I want you to do is do 480 mils of lactated ringer solution over a 4-hour period using a 15 GTT administration set. So, oh my gosh, this is not minutes, it's hours. I've never done this before. It's okay. We still have the same thing. We have 480. Okay. If we have 4 hours, how many minutes is that? It's 4 times 60. 4 times 60 is 240. Okay. We are going to use, so that's this is mils per minute. Okay. We are going to use 15 GTTs per mil. Okay. So what does that give us? 480 divided by 240 is 2. All right. I always double check. Multiply that by 30 or 15, you get 30. 30 what? What's the unit? We cross off the mils, so that's going to be 30 drops per minute. How many seconds in a minute? 60 seconds. 30 divided by 60 is going to be 1 drop every 2 seconds. Okay? 1, 30 every 2 seconds. That's 1/2. So you may have gotten the answer. If you do 30 divided by 60, you're going to get the answer 0.5 to a fraction. So you see the 1 drop every 2 seconds. I do want you to do that because I can't count half a drop. Okay? So now we go to something a little bit more difficult. Constant rate infusions. We can give medications. We can spike a fluid bag with a medication to give it by IV infusion. The issue is that we don't want to give all of it at once, right? And we can't give fluids too quickly. So we want to give the right dose over a specific period of time. And when they write the dosage for constant rate infusions, it's often ordered in micrograms per kilogram per minute, which can be confusing because most drugs are available in a concentration that is milligrams per milliliter, and they're expressed through infusion pumps as a rate expressed in milliliters per hour. So how do we take all of these units and make them into something that we can understand? First, we're going to do this in a way that doesn't have a formula. Okay, so just so that you can understand this a little bit more um, organically. So we have a 44-pound dog, it's acute heart failure, and they want to give it 10 micrograms per kilogram per minute of dopamine. You're going to add 200 milligram vial of dopamine to a 1 liter bag of dextrose 5% in water. And the solution then, because you're doing 200 in 1,000 milliliters, so 200 divided by 1,000 is 0.2. That will be 2 mg per mil. We want to find the rate per minute that we're going to administer that solution to get the correct dosage. So we're looking for the rate. So we have the dosage. We want them to get 10 micrograms per kilogram per minute. We have the concentration of the drug in the bag, 0.2 mg per mil, and we have the size of the dog. So convert to the same units. So we want to get from pounds to kilograms, right? And this is probably the easiest thing that you will do. How do we convert from pounds to kilograms or kilograms to pound? When we're converting from pounds to kilograms, we have to realize that if we're measuring something in kilograms, the number is going to be lower because a kilogram is heavier. Okay? So 44 pounds divided by 44 pounds divided by 2.2 is going to give us 20 kilograms. So 44 divided by 2.2 is 20 kilograms. Okay. Now, so 20 kilograms. Now we multiply that by the dosage rate, right, to get our dose. So 20 kilograms times 10 micrograms per kilogram per minute is 200 micrograms per minute. So every minute we want this dog to be getting 200 micrograms with every minute. Okay? And this is, if you look at this, we're just removing units by putting them opposite each other. It's just a math thing. Now we want to determine how many mils per minute. So if we want to give 200 micrograms per minute, and we know that the concentration is 200 micrograms per mil, we're going to put these opposite each other. I'm sorry, that mil is not crossed off. The micrograms are crossed off. Okay, so then we have how many 200 micrograms divided by 200 micrograms, because it's the concentration, we want to give 1 mil per minute. Okay, 1 mil every 60 seconds. If we know that we have a microdrip and it's 60 GTTs per mil, then we have 60 drops per minute or 60 drops every 60 seconds, which gives us 1 drop per second. And that's going to give us the right amount to give to that pet. But we do have formulas and recipes that help us to determine these CRI calculations. And we're going to give you this formula. I would write it down and I would memorize it. We have to remember that whenever, and the nice thing about this formula is it will convert all of those, as long as you put the right units in, it will give you the conversion and give you the right unit out. The volume of the delivery fluid is equal to the volume of the drug added should be removed. So basically when we add, for instance, when we add 200 mils of dopamine, okay, we added a vial of 200 milligram vial of dopamine. I don't actually know how many mils that was, but it made this solution. So say it's 10 mils. If the concentration of that vial was 20 mg per mil, and that's 10 mils, we would want to take 10 mils of the fluid out first so that it makes that an actual 2.2 per mg per mil concentration. Okay, so here is the formula. There are 5 letters that you need to remember, and they are each associated, well, 4 of them are associated, actually, the 5 of them are associated with a unit, and the last number is the conversion factor. Basically, it takes the hours and the minutes in the units and gives you an answer with a milligram as a unit. Okay, so M is the number of milligrams. M equals milligrams of drug to add to the delivery fluid. So if you're trying to solve for M, you're going to put the formula like this. M equals dWV divided by R times 16.67. D is the dosage of drug in micrograms per kilogram per minute. Micrograms per kilogram per minute. Okay, milligrams, micrograms per kilogram per minute. W is the patient body weight in kilograms. Okay, so now we have kilograms. Okay, volume V is the milliliters of delivery fluid. So if I give you something in liters, you're going to automatically change it to milliliters. If I give you something in pounds, you're going to change it to kilograms. And rate is mils per hour, not mils per minute, mils per hour. And then this, again, is a conversion factor. It's a constant rate that will change, and we can actually figure out how that works, but we're not going to. We're just going to trust that anytime we use this, it's going to, if you put it in the right units, it's going to change so that your answer is in milligrams. Okay? So it's going to change all this. So drug dosage times the body weight times the volume divided by the rate times 16.67. There's another formula that gives us a rapid calculation if you have standard delivery, a standard volume of 250 mils and a standard delivery rate of 15 mils per hour. But that doesn't give you as much flexibility as this one. Some CRI drugs are dosed in milligrams. It's also, let me say this, it also is not safe to run fluids at 15 mils per hour for every pet. So if a drug, CRI drug, is dosed in milligrams per kilogram per hour, guess what you have to do? You have to convert it to micrograms per kilogram per hour. And so that when we go from milligram to microgram, it means multiply by 1,000. Okay. So this is, if we're doing a 250, so again, a constant volume at a delivery rate of a constant rate, if you can run the fluid at 10 mils per hour. So these only work if you know that you can run the fluid rate at a certain amount. There is a CRI that is commonly used of morphine and ketamine, and sometimes we add lidocaine to this as well, MLK, that is used for pain control and drugs. Okay, and this recipe so this is a recipe that has been figured out, is we add 60 mg of ketamine, which is at 100 mg per mil. So if you take, so how many mils is 60 mg per kilogram, or I'm sorry, how many mils is 60 mg if our concentration is 100 mg per mil? So these are things you should be able to figure out pretty much in your head. Oops, I don't know why that did that. 60 mgs, that's their dosage, divided by 100 mgs per mil. Will give us 0.6 mils. And think about that logically. If we're giving 60 milligrams of a substance and each mil has 100 milligrams in it, it's going to be, when you pull it out, it's going to be less than 1 mil. Okay. Now 60 mgs of morphine at 15 mgs per mil is going to be more than 1 mil. You will take 60 and you'll divide it by 15 and you get 4 mLs. Okay, and that's assuming that this is the concentration of those drugs. You just have to look at it. So 60 mgs of each, so 0.6 mils of ketamine, 4 mils of morphine are going to be added to that 500 ml bag of fluid. 4.6 mils of a substance is going to be added to a 500 ml bag of fluids, which means that we need to take 4.6 mils out of that bag of fluids before we add it. So then when those two drugs are added, the patient's weight in kilograms becomes that infusion rate in mils per hour. So if they are 20 kilograms, we're going to administer at 20 mils per hour. That means that the delivery dose is 1 ml per kilogram per hour, or 2 micrograms per kilogram per minute of ketamine and 2 micrograms per kilogram per minute of morphine. When we add lidocaine to dogs, remember cats are very susceptible to lidocaine. If we add lidocaine to dogs, we're going to add 500 milligrams of a 20 mg per mil concentration, so we make it an MLK mixture. And so this is a mixture that is a recipe that has been around for a long time, and we know that it's very safe, and we can run it at a certain rate safely. All right, so we have a couple of problems, and I want you to go through these. The veterinarian orders prednisone. It's 20 milligrams. We want to give it IM. So obviously this is going to be something that is a liquid. The vial is labeled 50 milligrams per mil. How many mils are you going to administer? So we know, we don't need to know the dog's weight at this point, because we know that the doctor has ordered 20 milligrams. We're just going to assume that they've checked the dosage rate and that is correct. So we're going to figure out how many mils that is by dividing by the concentration. So 20 milligrams divided by 50 milligrams per mil, is that going to be more than a mil or less than a mil? And that is something you should be able to figure out very quickly, and then you can check it by your with your calculation. So if each mil has 50 milligrams, but we only want to give 20 milligrams of that, then you're going to be giving less than a mil. So it's going to be a 0 point. In this case, it's going to be 4 milliliters. Okay. Next one. The veterinarian orders an injection of percortin 5 for a 20-pound dog at the dosage rate of 2.2 mg per kg. The concentration of percortin 5 is 25 mg per mil. How much of the drug should be injected? So it's a 20-pound dog. That's great. We have pounds. We have kilograms here. So what do we need to do? Change the pounds to kilograms. 20 pounds divided by 2.2 is 9.1. So 9.1 is our weight in kilograms. 0.1 kilograms. And we need to multiply that by the dosage rate, 2.2. We just divided by 2.2. What is that going to give us? 22 mg per kg. So if we look at the units, we can erase the kilograms. So 9.1 times 2.2 is 20 milligrams. Okay, so 20 milligrams, and we need to divide by the concentration, 25 milligrams per mil. Is that going to be more than a mil or less than a mil? Well, if this number is smaller than this number, it's going to be less than a mil. This is a fraction. So 20 divided by 25, it's going to be close to a mil, is 0.8. Whoop, so bad at this. 0.8 mils of percortin. Okay, so we need to pay attention. I mean, we're seeing the words here, but honestly, we're just plugging these numbers into what we know. Dose times dosage rate times, or dose times weight divided by concentration. The veterinarian orders phenylbutazone, this is bute, to be administered to a 1,500-pound horse at a dose of 5 mg per kg. So automatically we need to do what? We need to take 1,500 pounds and convert to kilograms. So 1,500 divided by 2.2 is 681.8. 681.8. So how far do we take these decimal points? If it's a bigger number, we're going to take it out to the 10th. If it's a smaller number, we'll probably take it out to the 100th. Now we need to, so we've got the weight. Now we need to multiply by 5, right? 681.8 times 5. That's going to give us 3,409 milligrams. Okay. We're going to divide that by 200 milligrams per mil. That's the concentration. So how many mils are we going to give this animal? 17 mils. Okay. Next one. Penicillin G procaine for a 25-pound dog. It is, oh no, here's another unit. It doesn't matter because our concentration is in units. Okay, otherwise we'd have to have a conversion from units to milligrams, but we don't need one because we can make this happen. Now, the one thing that doesn't add up or doesn't match is our units for pounds and kilograms. So again, you're going to do 25 divided by 2.2. That's going to give you 11.4 kilograms. 11.4 times 40,000 is 454,545.45. We're going to divide that by 300,000 units, and we're going to get 1.5 mils. 1.5. If you didn't get 1.5, where you're still trying to figure out, go back and take a look at that. Dose times weight times, or divided by concentration. Cefazolin, 23-pound dog, pounds, kilograms, 20 mg per kilogram. So 23 divided by 2.2 times 20 is 209. The concentration is 100, so divide 209 by 100, you get 2.09. Okay, 2.09. So it's 209 milligrams. How much? How many milliliters is 2.09? So look at the question, see what we're asking for. What unit are we asking for? Okay, make sure you pay attention to that. A 78-pound dog administered ampicillin trihydrate at 5 mg per pound subcutaneously. Oh, good. We don't have to convert that. So 78 times 5 means we have given 390 milligrams. The antibiotic was reconstituted and the concentration is 200 mg per mil. So we have to give 390 milligrams, divide that by 200, that's 1.95 milliliters. So look for what we're looking for. If I had asked for milligrams, you would give me 390. Microscopic fecal exam reveals Giardia, 500-gram African gray parrot. Uh-oh, it's grams. Our dose is in kilograms. Golly, what will we do? So remember, if we're how many kilograms is a 500-gram parrot? If we're going to figure out, we're going to go up the steps. 500 grams divided by how many grams per kilogram? 1,000. Okay, grams per kilogram. Okay, take the grams away, and this gives us 0.5 kilograms. Okay, 0.5 kilograms is our weight. We want to give, here's our dose, times 30 mg per kg, m per k, is going to give us 15, so half of 30, 15, wow, 15, this is bad, 15 milligrams. Okay, so we asked for milligrams. You may be looking for concentration. We didn't ask for concentration. Even if I give you concentration and I ask for milligrams, give me milligrams. Now we have a boar. It's 500 pounds. We want to give this boar 5 mg per pound per day for 5 days. The medication on hand is 100 mg per mil in a 50 ml multi-dose vial. How many milligrams are going to be administered to the boar each day? Sometimes we need to just take it step by step and see what we can actually, numbers we can actually ignore. Okay, sometimes there are numbers there and they don't actually fit into it. So just take it step by step as you know it. 500 pounds weight times 5 milligrams per pound dose. 500 times 5, 2,500. 2,500 milligrams a day. Okay. The medication on hand is 100 milligrams per mil, so we want to divide by the concentration. 100, 2,500 divided by 100 is 25 mils each day. I'm sorry, 25. Oh, shoot. What did I do? I want to know how many milligrams. We don't want to divide by 100 milligrams per mil. Go back. We want to give 2,500 mgs per day. So look at this. I need to remember that that answer that I want is milligrams. If you take it the rest of the way and one of the answers is 25 mils, you're going to get it wrong. So you want to make sure that you stop when you need to stop. Okay? Even if we give you concentration here, I'm not asking for that. So here is where I asked for it, 25 mils. Okay. How many bottles of medication does the owner have to purchase to treat the boar for 5 days? Ooh, good thing that we need to know this one now. Okay. We have a 50 ml bottle. We have to give 25 mils a day. So how many days will this last us? 2 days. Okay. We need to treat for 5 days. So we need 2.5 bottles, or we don't never give a half bottle, 3 bottles. Okay. So this is practical calculations. We need to know how many bottles to give them. We have an 8-pound cat, small laceration. We want to give it ketamine. The veterinarian orders 15 mg per kg IM, and the vial is labeled 100 milligrams per mil. How many milligrams will be administered? Okay, so we're going to stop at the dosage times or dose times weight, but kilograms, pounds. 8 divided by 2.2 means we are 3.64 kilograms. 3.64 kilograms times 15 gives us 54.5 milligrams. Now we're going to take that number and divide by the concentration. Divide by 100, that's going to give us 0.54 milliliters. Okay? So remember what we're looking for. Drip rates. Let's go over drip rates. Drip rate. What drip rate will you use to administer 500 mils? Just start writing down numbers. 500 mils. That's the volume. Over 3 hours. 3 hours. with a standard 15 GTT mils administration set. So how many minutes in 3 hours? 3 times 60 gives us 180 minutes. Okay? So 500 divided by, oops, I apologize. There we go. 500 divided by 180 is going to give us 2.78 mils per minute. Let's just call that 2.8 mils per minute. Which again, we're not going to sit there and count mils per minute, right? Let's change this to 2.8 mils per second, and then we'll change it to drops per second. So how do we change it to second? 1 minute is 60 seconds. So multiply by 60. So it will be 2.8 divided by 60 is 0.05 mils, 0.05 mils per second. Now we got to convert to GTTs. And if we know we're using a 15 GTT per mil, 15 GTT per mil, all we have to do is multiply 0.05 times 15. That gives us 0.75 drop per second. All right, friends. Can we count a three quarters of a drop? No. So we're going to take this and turn it into a fraction. That's 3 drops every 4 seconds. Okay. So that's one way to get it down to something you can actually count. It's almost a full drop a second, but not quite. Okay. So we need to remember how to take it down to from mils per hour to mils per second, and then from mils to drops per second. Okay, so that's the drip rate. If we're using a drip rate, we want to figure out a drip rate for 120 mils of 0.9% solution. Again, here is a number that we may need to ignore. 0.9% solution is just telling us what type of fluid we're using. It's like saying dextrose 5% water or LRS. So we're taking 120 mils over 2 hours using 60 GTT administration set. So go back to this, 120 mils. 2 hours is 120 minutes. 2 times 60. Okay. Okay. We can do, so if it's 120 divided by 120, that's going to be 1 mil per minute, or 1 mil every 60 seconds. Okay. If we know that 1 mil equals 60 drops, that means we're doing 60 drops every 60 seconds. That's 1 drop per second. Okay? So what drip rate, next question, would you use to deliver 1.2 liters of Normasol over a 10-hour period using a standard 15 GTT mil administration set? Liters, mils. Uh-oh. Let's change that. 1.2 liters is 1,200. If we multiply by 1,000 milliliters. Okay, over 10 hours or 600 minutes. 60 times 10. Okay, 1,200 divided by 600 is going to be 2 mils per minute. Getting worse. 2 mils per minute. Okay, 2 mils per minute or 2 mils every 60 seconds. Okay, 2 divided by 60 is 0.03. 0.03 mils a second. Okay, and we multiply that by 15 drops per second. I'm sorry, 1 second. Oh, we need to actually put that the other way. So every second we're doing 0.03 drops, or 0.03 mils. Okay. No, I'm sorry. That's not what I want to do. We want to change drops to or mils to drops. So we're 0.03 drops or mils per second times every second. I'm sorry. I'm doing this wrong. Every mil has 15 drops. Okay. So we multiply 0.03 times 15. That gives us 0.45 drops per second. Okay. Which is 1 drop every 2 seconds. Okay. If you are having difficulty changing this decimal to a fraction, divide 1 by this decimal, and that will give you 1 on top and whatever number you get on the bottom. So 1 drop every 2 seconds. Okay. If it's 0.8, if we get 0.8 drops, take 1 divided by 0.8, you will get 1 on top and 1.25 on the bottom, which means that's 1 1/4. So we need to change that. If that's 0.25 divided by 1, that's 4. 1 divided by 0.25, that's 4. So we need to change this 1 1/4 or 3/4. So it's 1 over 3/4, 1 over 3/4, or 4/3, sorry, 4/3. 1 over 4/3 is 3 drops every 4 seconds. So it's a matter of changing your decimals to fractions. All right, another one. What drip rate would you use to deliver 8 micrograms per kilogram per minute of drug C, whatever the drug it is, which is 500 milligrams every 250 mils to an 83-pound dog using a microdrip 60 GTT per mil administration set? Sounds horrible, but we can do this, okay? So we can take this this concentration, first of all, and make it, instead of saying it as 500 mgs per 250 mils, 500 divided by 250 is 2 mgs per mil. 2 mgs per mil is a concentration. 83 pounds divided by 2.2 is 37.7 kilograms. Okay. If we're delivering 8 micrograms per kilogram, we are delivering, if you take 37.7 times 8, you get 4, sorry, that's not right. I did a divide. 8 times 37.7 is 301.6 micrograms per, that's our dosage rate. Okay? Micrograms. Well, micrograms are not milligrams, right? So we want to change that to milligrams. So how do we do that? Micrograms to milligrams, there are 1,000 micrograms in each milligram. Okay, actually you want to switch that around. So 1,000 micrograms in each milligram, and I'm going to take 301.6 milligrams, multiply it by 1,000, and so that means that this dog is going to get 300, instead of 301.6 milligrams, it's going to get 301,600 micrograms. I'm sorry, I did that the wrong way. 301.6 micrograms strike that, go back, micrograms to milligrams. So we want to divide by 1,000 because milligrams, there will be much less milligrams than micrograms. So 301.6 divided by 1,000 is 0.3, 0.330 milligrams. Okay. 0.3 milligrams, change that to milliliters. There are 2 milligrams per milliliter. So if we take 0.3 milligrams and divide it by 2, you get 0.15 milligrams per minute. We're still on per minute. So that's a very small amount. Okay. 0.15 every 60 seconds is going to be 0.002. It's a very small amount. 0.002 mils per second. And then we're going to, how many drops? 60. We're going to multiply 0.02 times 60. 002 times 60. And we're going to come back with 0.15 drops per second, or take 1 divided by 0.15, and you get 1 drop every 6 or 7 seconds. 1 drop every 6 to 7 seconds. Okay, so really slow rate of infusion for that guy. Drip rate to deliver 10 micrograms per kilogram per minute of dopamine, 0.2 mg per mil, to a 22-pound dog using the microdrip 60 GTT mils administration set. So come back here, 22 pounds, that's 10 kilograms. 10 kilograms times the dosage rate, 10 times 10 is 100 micrograms per minute. 100 micrograms per minute. 100 micrograms is the same as 0.01. So you divide by 1,000. I'm sorry, 0.1, 0.1. Let me write that again. 0.1 milligrams per minute. Divide that by the concentration. 0.1 divided by 0.2 is 0.5. 0.5 mils per minute. Okay, and then we are going to understand that there is 60 seconds every minute, so 0.5 divided by 60 is 0.08. It's 0.08 mils per second. Now we multiply it by 60. 60 drops per mil. So it's 0.8 times 60, going to take us back to this number here. 0.5 drops per second, which is the same as 1 drop every 2 seconds. We're going to add 7 milliequivalents of potassium chloride to the IV fluids. The vial is labeled 20 milliequivalents in 10 mLs. That's a concentration. Okay, so 20 milliequivalents in 10 mils is going to be 2 milliequivalents per mil. So how many mils? It's 7 divided by 2. The dosage divided by 2. 7 divided by 2 is 3.5 mils. Okay, and again, you take 3.5 mils out and put 3.5 mils in. The veterinarian orders 4 units of regular insulin to be administered to a diabetic cat. The regular insulin is 40 units per mil. So if we're giving 4 units and the concentration is 40 units per mil, how many mils? Now, be aware that most of our insulin is given in units, but this is just one way to do a concentration. So 4 divided by 40 is 0.1 mLs. Okay, that's it for now. We are going to do some CRIs in class and a little bit later, but you should be able to go through these. They should make some sense to you, and we'll talk more about this in class.